Welcome back to part 3 of our Ollama AI Assistant series. In the previous video we transformed our simple AI tool into a complete ChatGPT style application. We added conversation memory, multiple chat support, automatic model downloads, chat history, and a modern user interface. But today we're going to make our AI assistant feel much more alive. Because right now our assistant can talk to us through text, but it can't actually speak. Let's change that. By the end of this video our AI will be able to read its responses aloud using the built-in Windows speech engine. Everything will still run locally. No API keys. No subscriptions. No monthly fees. And no cloud services. Let's get started. The first thing we need is access to the Windows speech engine. For this we're going to add a COM reference. Right-click your project. Choose Add Reference. Select COM. And then choose Microsoft Speech Object Library. Press OK. This gives us access to the SpeechLib namespace and allows us to use the Windows speech engine directly from C#. Now let's switch over to our code. At the top of the file add the SpeechLib using statement. Next we're going to create a few new fields. We'll need a button for controlling voice output, a flag that tells us whether speech is currently enabled, and finally an instance of the SP voice class itself. The SP voice object is responsible for converting text into spoken audio. Think of it as the voice of our AI assistant. Now let's improve the startup experience. Inside the constructor, directly after building the user interface, we're going to load the best available voice on the system. This allows us to automatically select a good voice if one is available while still providing a fallback for other machines. Let's create the load best voice method. The first thing we do is retrieve all installed speech voices. So it's possible that you see only the method getVoice instead of getVoices. That's because there are actually different versions/interfaces of Microsoft Speech API, SAPI, exposed through COM, and Visual Studio can generate slightly different interop assemblies depending on which reference you selected. So just try to select a different speech object. If it's not there or still not working, you can also leave this method empty, then you're still able to do the rest of the following code and use the standard voice. So if you have the right method, let's do the final steps. Then we select the first available voice as a fallback. This guarantees our application always has a valid voice available. After that we loop through all installed voices and search for Microsoft Zira. Zira usually sounds more natural than many of the older Windows voices. If we find it, we use it. Otherwise we simply keep the default voice. Finally, we configure the speech rate and volume. This gives us a slower and more pleasant speaking speed. Now let's create the method that actually performs the speech. The speakText method receives a string and passes it directly to the Windows speech engine. We're using asynchronous speech so the user interface remains responsive while the AI is talking. Next, we'll create a stop speaking method. This allows us to immediately stop any active speech whenever we need to. Now let's improve the user interface. Inside Build UI, we're going to add a new button. This button will allow users to enable or disable voice output whenever they want. Let's call it BTN, Speak. We'll give it a speaker icon. Configure the size. Apply our dark theme. And then add a click event. Every time the user clicks the button, we'll simply toggle the auto speak flag. If speech is enabled, we'll show voice on. If speech is disabled, we'll show voice off. This gives users full control over the assistant. After creating the button, don't forget to add it to the right side panel underneath the Send button. Since we're adding another control, we'll also increase the height of the input area slightly. Now let's connect everything together. Inside Send Message, we're already generating AI responses. After the response has been completely generated and added to the conversation history, we're going to check whether voice output is enabled. If it is, we'll simply call SpeakText and pass the generated response. And that's it. Our assistant can now speak. One final improvement before we test everything. Let's override on. Form, closing. When the application closes, we'll stop any active speech. This prevents the voice engine from continuing after the application has been closed. Now let's add one final improvement to our AI assistant. A system prompt. At the moment we're sending the conversation history to the model. But we haven't actually told the AI how it should behave. That's exactly what a system prompt does. Think of it as permanent instructions for the model. Every time the user sends a message, these instructions are included automatically. So first let's create a simple string variable. Inside this string we can define the personality and behavior of our assistant. For example, we can tell the AI to be helpful, friendly and provide clear explanations. You can customize this however you like. Maybe you want a coding assistant, a teacher, a technical support agent, or even a gaming assistant. The choice is completely yours. Now that we have the system prompt, we need to include it in our conversation builder. Inside Build Conversation, before we add any chat messages, we'll append the system prompt to our string builder. This ensures the AI always receives those instructions first. Only after that do we append the conversation history. The result is a much more consistent AI experience. The model now understands its role before it sees the user's message. And with only a few lines of code, we've made our assistant feel significantly more intelligent and professional. It's a small change, but it has a surprisingly big impact on the quality of the responses. Now let's run the application and see what we've built. The first thing you'll notice is our new voice button. Voice output is currently enabled. Let's start with a simple question. I'll press send. Notice how the response streams into the chat window exactly like before. But now something new happens.
Locally AI offers control, data security, and faster processing speed compared to cloud services, ensuring private and swift computing.
As soon as the response is finished, the assistant begins speaking. Our local AI can now communicate using both text and voice.
You're welcome. It was my pleasure to assist you. I hope you have a great day as well. If you have any more questions or need help with anything else, feel free to ask. I'm here to help.
In the next part we'll take things even further. We'll add microphone support using speech to text. Instead of typing prompts, users will simply speak directly to the assistant. We'll turn our project into a true voice-controlled AI assistant. If you enjoyed this video, don't forget to like, subscribe and leave a comment. And let me know. Would you keep voice output enabled all the time, or only for certain tasks? Thanks for watching. And I'll see you in part 4.